Hello, ladies and gentlemen. It's time to talk about how to find area of regular polygons, so regular shapes. For this, you're going to need a pencil, a calculator, and that formula sheet, but we're not going to write a formula on it just as a reference. You're going to need to write 2 examples in your notes today, and those 2 examples are going to guide you as we go forward finding areas of other regular polygons, okay? So you're going to need 2 examples, I should put an S on that, into your notes to make sure that you have a guide to follow in the coming days. So first we need to start with the parts of a regular polygon. Please draw this picture into your notes, okay? Parts of a regular polygon. There are going to be some key words that come up in our descriptions, and we need to be able to draw a good picture and also label those pictures correctly. So you'll notice this is a 5-sided shape. It's a pentagon. And each pentagon or each octagon or hexagon or whatever it is has something called a side. You should know that those sides are always going to be all equal in length, and that's because the shape is regular. That means it's perfect. That means all the sides and all the angles are exactly the same. So the sides will all be equal in length. If I was going to label a side on my picture, obviously we would know that a side would be around that outside edge of this pentagon. But there is also something called a radius that we would want to draw. And a radius is the distance from the center to a vertex. So from the center of this pentagon there, drawn to the vertex or a corner. Okay, corner of that shape. That is the radius. I'll go ahead and label that on my picture here. And also we could draw in this shape something called the apothem or the apothem. It is the distance from the center to a midpoint of a side. So if you were to drop a line straight down from that center to the side there, that is called the apothem or apothem, depending on how you want to pronounce it here. I've heard it both ways. Now notice in there, when I draw these pieces in, we made a little triangle. This is going to be the key to our work in finding the area of a regular polygon. That's going to be the key, is seeing that triangle each and every time. So let's actually do a couple examples here. First one, write this in your notes and you need to draw a good picture. So write the description and draw a good picture. You could pause it now to make that happen and then start it right back up, okay? We need to find the area of a regular pentagon with sides of 4 inches. So this is what the picture looks like, ladies and gentlemen. We have sides at 4 inches all the way across because it's regular, and we have a regular pentagon. It has 5 sides here. So within this picture, we want to remember that the key to finding the area is focusing in on drawing that triangle that we just found with those 3 key words, okay? We need to be able to draw that triangle. But before we get that triangle in this picture, notice that we have all our sides labeled with the correct degrees, but we also need to label all the angles with the correct degrees. So in my pentagon, let's figure out what the total degrees would be for a 5-sided shape. To do that, we would take 5 subtract 2 and times 180. That's the number of sides subtract 2 times 180. And if you calculate that, that is 540 total degrees. But if I split that up 5 ways, because I have 5 angles, so if I divide by 5, 540 divided by 5 is 108 for each corner. I would label those in my shape as well. I'm going to leave this last corner unlabeled, and you're going to see in a moment just why that is. So remember, if we take this pentagon and we want to draw in a little right triangle right here. So you'd want to sketch that triangle inside there. Notice that I didn't label the 108 degrees. That's because when you draw this triangle in, ladies and gentlemen, we made a right triangle down here. And that right triangle, only part of that 108 degrees, this whole angle was 108, but how many degrees are inside that triangle? Only half of that. So I have 54 degrees inside the triangle here. 54 degrees would be outside, making the 108 degrees total for that corner of that pentagon. Now that triangle is going to play a key role in us finding the area, because if I could find the area of this one triangle, I could then use that fact and how many triangles would be spiraling around inside this pentagon here, and that would help me find that total area of the pentagon. So there is no area formula for a pentagon that we're going to use. We're going to base all of our formula calculations on this one triangle right here in the corner. So let's pull that triangle out to the side in your notes, okay? Please do that. Write that triangle in your notes. I'm going to move a little bit on my total degrees here. And that triangle is going to be our focus. Remember, he was a right triangle. Do you see how this became 2 inches right down here? It's not 4. Remember, our triangle was only half of that side. That's a big deal. The whole side was 4, and when I pulled that triangle out, it has a base now of just 2. Remember, in the corner here was 54 degrees. And now let's think about how we can find the area of a triangle. Area equals base times height divided by 2. I know the base of that triangle is 2. Do you know the height of the triangle? Nope, not yet. We're going to put an X on that, and we're going to use a little SOHCAHTOA or a little trigonometry here to help us find that height so that we can find that area. So what would we set up? Well, if I'm at the 54 and I'm looking opposite and I have adjacent here, then I would use tangent. I do tangent of 54 equals opposite over adjacent. So I would go ahead and type into my calculator what the tangent of 54 is. Tangent of 54, that's 1.3764 equals x over 2. Place him over 1 and cross multiply. X equals 2.75. So this triangle has a height of 2.75. I'm going to write that in my picture now. So now that I know that, I can finish finding the area of that triangle. So area equals base of the triangle times the height of the triangle divided by 2. So 2 times 2.75 divided by 2 gives me an area of 2.75 inches squared. Now remember what we just found there? That's the area for just this one little blue triangle that we have. One triangle that would be fitting in that pentagon. But think with me how many of those triangles could fit inside here. That's one located in that one spot. I could also draw a triangle over here. That would be the same triangle. It would have the same area. I'd draw one here to the center of that side, another triangle. Draw one to that corner, another triangle. And I could keep doing this all the way around my 5-sided shape. Notice that for every side, there are 2 triangles that fill up that side. So on a 5-sided shape, I would have 10 total triangles. So I would take my area times 10, and I get 27.5 inches squared for the total area of my pentagon. So notice how the one area comes from finding the area of that triangle and figuring out how many of those triangles would fit inside that shape. That's a big deal. Okay, let's look at another one. Let's find the area of a 6-sided shape this time that has a radius of 9 inches. So a 6-sided shape is a hexagon, and it has a radius of 9 inches. This time, we don't have a side length, we have a radius given to us. Radius comes from the center to the corner like that. That is 9 inches. So if we think about our little triangle inside of our hexagon here, I'm going to draw another one of those little triangles. We know that radius there is 9 inches. That would be on the hypotenuse of my little right triangle, on the slanted side, okay? So I need to find the area of that little triangle, and then I can multiply it by all the triangles that would fit inside there, and that's our plan. That's how we can get the total area of this hexagon. In order to do that, though, I'm probably going to have to use a little trigonometry to find anything that's missing. So we have to go back to our understanding of degrees. This is a hexagon. How many total degrees does a hexagon have? A hexagon has 6 sides. 6 minus 2 times 180. If you calculate basically 4 times 180 then, 4 times 180 tells me that a hexagon has 720 total degrees. But I have 6 angles in a hexagon to split that between. That means I have 120 degrees. Oopsies, 120, 120, 120, 120, except here in this little corner where I've drawn my triangle, my 120 would be split evenly, so I'd have a 60-degree angle right there. Okay, 60-degree angle. So here's what would happen then. We take that little triangle and we just work to find the area of that little triangle. 60 here, 9 inches here. We need to use the area formula for a triangle, which is 1/2 base times height, or base times height divided by 2. Maybe I'll stick with that. Base times height divided by 2. And that will give me the area of that little triangle. Now, wait a minute. Do I have the base? Nope. Do I have the height? Nope. So this causes a little bit of a problem. We'd have to do a little trigonometry to help me find both of them. That's a possibility. So if I want to go x there, that would be the base. And I would set up maybe a cosine. Cosine is adjacent over hypotenuse. You could do cosine of 60 equals x over 9 and solve for the base that way. That's totally doable. That's fine. You could also do something from a 30, 60, 90 degree triangle shortcut. If you remember your 30, 60, 90 degree triangle shortcut, it was the hypotenuse equals 2 times the short leg. So my hypotenuse is 9. 2 times the short leg is x. So that tells me that my x labeled in my picture here would be 9 divided by 2, or 4.5. So that got me that answer pretty quickly, but you have options. You just need to find a way to figure out that base. So that base would be 4.5. Now, do we have the height of this triangle? No, we don't have that either. So that'd be like a y that we need to find, or an h if you want to label it with that. So again, we either need to use SOHCAHTOA to find that, or 30, 60, 90 degree shortcuts, or now Pythagorean theorem, whatever, but we have to find that height. Now, if I'm at this 60 degree angle here, we could do opposite over hypotenuse. You could do a sine of 60 equals y over 9. This is a possibility. You could also say long leg equals short times the square root of 3. So that would be my long leg. Y equals 4.5 square root of 3. That would be fine. Okay, you could just multiply that out and convert that into a decimal if you wanted to. So either way, you need to find a way to find that base or that height. So I'll just use what I did here with my 30, 60, 90 degree shortcuts because they're a little bit faster. And now that I know area equals, the base is 4.5. That's the x. Times the height, 4.5 square root of 3. And then I'm going to divide that by 2. So I'll just go to my calculator, 4.5 times 4.5 with the square root of 3 behind it equals, and then divide by 2. I get an area of 17.54. Now we'd label that with inches squared. I'm going to circle that. That's the area of just that one triangle that we drew out to the side. The hard work's been done. One triangle is done. Figure out with me how many triangles we would have going around this shape. Each side gets 2, right? 1, 2 triangles on that side. 1, 2 triangles on this side. If I have 6 sides, each of them with 2 triangles, that would give me 12 triangles that I'd be finding on a hexagon. So this answer here is going to be multiplied by 12, 17.54 times 12. And that gives me a total area of 210.4 square inches. So it all comes down to this, ladies and gentlemen. It all comes back to this. You need to know how to draw a hexagon and what that means. You need to know where a radius is, how many total degrees there are. Divide it out correctly. Be able to draw a little right triangle. Use your right triangle tools to find a missing piece that you might need. Find the area of one little triangle, multiply by how many triangles you'd have. These are the steps that we need to go through in order to figure out the area of any regular polygon. Okay, so work through it. It's a process, but you know all the tools to help get you there. You just need to be fluent in those tools and be able to figure out flexibility here in your problem solving, figure out what you need in order to find that area, okay? So I want to thank you for taking good notes, and I look forward to seeing you. Bye.